So first of all, we will going to study in detail that what actually data encapsulation is. So first of all, data encapsulation happens on a sending machine. So in our example, the machine A is the sending machine and the machine D is the destination machine. The communication is happening on the application 1, which is running on the sending machine, and application 2, which is running on the destination machine. And let us suppose that the application 1 wants to send a very simple data to the application 2, and let the data be just "how are you?" just a text message. So let us see what happens in data encapsulation process that will happen on machine A when machine A tries to send a data to the machine D. So the application running on the machine A is app1, which generates a data, which is simple a text message, "how are you?" So the data that is generated by the application is called application data. Once the data is generated by the application passes its data to the layer running below it, that is the transport layer. The transport layer receives the data from the application, and the transport layer attaches its own header. And as I have already mentioned, that the transport layer encodes the identity of the receiving machine and sending machine. So here the transport layer encodes the identity of the receiving process running on the destination machine D. Optionally, the transport layer may also choose to specify the identity of the sending process, that is app1. So once the transport layer attaches its own transport header, it passes the rest of the message to the layer running below it, that is the network layer. The network layer attaches its own header called network header. And again, the network header means encoding the information of sending machine and receiving machine. So the sending machine is A and the receiving machine is D. So once the network layer has encoded its own network header, it passes the combined message to the next layer running below it in the TCP/IP stack, which is a data link layer. And data link layer does the same thing. It attaches its own header called MAC header, which contains the MAC address of the machine A and the MAC address of the machine B. So where from this machine B came? So machine B is a machine which is next hop towards D from A. It means that if A wants to send the data to the destination machine D, then B is the next hop. So MAC header encodes the information in the form of MAC addresses, that is MAC address of the machine A and MAC address of the next hop. And eventually the data link layer places the data on the wire. So this is a big picture of what happens in data encapsulation on sending machine. Here are few points to note here are that whenever any layer attaches its own header, it do not even read the other headers which are already attached by the layers above it. Every layer is just concerned with its own header. It never examines or it never reads what is there in the other headers which are already present in the packet. This is true for data encapsulation as well as data decapsulation.